Okay, let's continue from the last day lesson. So we were just learning about the potential difference and actually the voltage difference between 2 points here. So if you can remember like this, we have just created these circuits using our virtual environment, which is Tinkercad, and then measured the voltage difference. So this is actually the potential difference. 1 point is actually, it has high potential, the other point has low potentiality. So whatever the potential difference is known as the voltage actually. So we can measure that using a voltmeter or even using a multimeter. So basically now we know how to measure this. Actually there are DC current as well as AC current. AC current is the current that we are using now in our day-to-day life, which is delivered by this electricity board, that is AC current. So AC current, basically we are getting that around 230 volt. That is the potential difference. But DC current, typically in a normal battery, DC current, the potential difference is around 12 volt. So the thing is, when potential difference is very high, like 230, so it is like basically when it is above 100, so it is possible to get electric shock if you are exposed to that electricity. So there is a high potentiality to get electric shock. But if potential difference is low, like 12 volt, even amperage is high, you will not get electric shock. Normally you will not get. But when potential difference is very high, so it can even be deadly. So like 11,000, high tension lines, 11,000, 33,000, these high tension lines are deadly. So once you get electric shock, so you might die. So that is how dangerous, like when potential difference is high, it is dangerous, right? Okay, then to detect defects, right? To detect defects electric appliances. So normally we used to measure the potential difference or the voltage, and also we can measure the power, amperage. Right, those things can be used to measure and so to identify whether there is some issue. So for an example, if your device is using a battery, so let's say a car or a bike, if it is using a battery, if it is not starting, so you can use a voltmeter and check the battery voltage. So if it is like less than, let's say 12 volt battery, normally 12 volt battery will maintain voltage around 12.5, 13, 13.5. So which is something about 12.5. But if it is around 11, 11.5, something like if it is dropped down, then most probably the device won't work. Your car won't start. So to find the defects, to identify the defects, so ඒ වගේ ප්‍රශ්න කායක start වෙන්නේ. අපිට බලන්න පුළුවන් voltmeter එකක් හරි එහෙම නැත්නම් multimeter එකක් හරි තියලා battery එකේ voltage. So ඉස්සලම අපි බලන්නේ ඒක. ඒතර voltage එක drop වෙලා නම් 12ට වැඩි අඩුයි නම් ගොඩක් වෙලාවට ඒ කියන්නේ වැඩ කරන්නේ නැහැ. සාමාන්‍යයෙන් 12ට වැඩියෙන් maintain කරනවා. ඒකල normal situation එකේදී 13.5ක් විතර තියෙන්න පුළුවන්. If you are using a solar system, you might. But then solar system එක උනත් battery අපි තුන් වහින දවස් කියලා මේ වගේ දවස්වල වහිනවා. එතකොට ඕගොල්ලෝ දැන් 12 volt battery එකක්. If you are using a 12 volt battery in a solar system, so you should not use that. If it is around 12 volt, you should not use that continuously. The 12 volt කියලා අපි හරියටම අපි තුන් 12.3ක් වගේ තියෙනවා. 12.2ක් තියෙනවා කියන්නේ. ඒ කියන්නේ එච්චර සුදුසු නෑ ඔයාලා දිගට මේක use කරොත්. හේතුව 12 volt battery එක සාමාන්‍යයෙන් normally 13.5ක් වගේ තියෙනවා. අඩුම ගානේ 12.7ක්වත් තියෙනවා. ඒතර ඒක 12.3, 12.2, 12 ඒ වගේ වෙනවා නම් ඒ කියන්නේ බැටරි එක ගොඩක් වෙලාවට මේ ඩෙඩ් වෙන්න ළඟයි. නැත්නම් බැටරි එකේ වෝල්ටේජ් එක ඉවර වෙන්න ළඟයි. ඊට වැඩිය ගොඩාක් ඩ්‍රොප් වුණොත් සමහරවිට බැටරි එක සවුත් වෙන්නත් ඉඩ තියෙනවා. Therefore you need to be careful with these voltages. Okay, then so why these voltage measurements are used? To identify the defects, to measure the electricity power, and to identify whether parts are properly working or functioning. And if it is a solar system, to identify whether this is charging or not. For that you need to measure this. And this is for your extra knowledge, very sensitive voltmeters and ammeters assembled using digital technology, right? So now actually they are commonly used. So they are very high in sensitivity. Therefore, they can even measure small fractional points, and it is easy to use. So these are nowadays we are having these digital multimeters and digital voltmeters, etc. But what you can see here in this image are not digital. These are basically analog. This is using a magnet, analog base. And this is also this galvanometer, ammeter, milliammeter, all these are analog. But so actually if it is having a display like this, mostly it is digital. Okay, then resistance. So I hope that we have learned about the resistance last day. If not, let me check the notes quickly. Electrical charge. Yes, I hope we discuss about resistance. Resistance is basically material's tendency to resist the flow of charge. Why this is happening? So what are the reasons? Why this can be happen? Resistance. So what are the reasons? Resistance එකක් එන්න පුළුවන් කොහොමද? Resistance කියන්නේ මේ ධාරාව නැත්නම් මේ electric current එක. ඒක ගමන් ගන්න තියෙන බාධක ගතිය. බාධක සහිත ගතිය තමයි resistance කියන්නේ. Yes. ඇයි මේ resistance එකක් එන්නේ? Why resistance is there? So what are the reasons? ඉතන විදියට කියන්න පුතේ. ඇයි resistance එකක් එන්න පුළුවන්? මොනවාද හේතු?
To minimize high electric current.
ඔව් එහෙමත් පුළුවන්. Purposely අපිට පුළුවන් high potentiality එකක් අඩු කරන්න. හරි ඒ කියන්නේ resistor එකක් දාලා අපිට පුළුවන් අර අපි circuits වල use කරේ නේද ඔයා ඒක part එක තමයි අපි මේක හරි මම අහන්නේ මේකයි what I'm asking so why there is a resistance ඒක ඇත්ත purposely resistor එකක් use කරලා power එක මේ වගේනේ අපි යමුකෝ circuit board මේකට Okay, let me use a coin cell battery and a resistor and a LED. Connecting the LED anode to the resistor and back to the anode and cathode. I'm going to connect like this. Let's use, okay, I'm not using the switch, just directly connecting them together. And let's see when you're running, what will happen. You can see bulb is turned on, but we can measure this using multimeter. I just need to measure the voltage and putting this in the negative and positive edges. You can see it's 1.83 volt. So when I use the edge and I'm connecting this resistor, then both resistor and LED, it is, you can see 2.9 and this battery is providing 3 volts, so it's 2.99. Around the LED 1.8. So let's say around the resistor it is, if 1.8 around this, then there should be 1.2 around this, 1.16. So it is basically to share the potential difference. Potential difference means voltage. That is also correct. Any other reasons? Actually, this can be taken as why we are using resistors. Resistors can be used to reduce the amount of potential difference. The resistor can be used to reduce the amount of potential difference. Okay, that is how we are using resistors now. I'm asking why resistance is there. Resistance why resistance is there. So what's the reason? Resistance
because low the power.
Yes, because
Low the battery power.
Yes, that is again the same. You are telling the same reason. To lower the battery power means like battery is providing 3 voltage, but you know the bulb, if we give 3 voltage to the bulb can be burned. So therefore, we are to reduce the battery power or the potential difference, we are using resistor. So then actually in between the resistor and so both resistor and LED will share 3 voltage, but LED will be individually, LED will be given a less potential difference, and LED will get around, oh, sorry, that's my mistake. LED will get 1.8 volts. That is actually purpose. Why resistors are used. But understand my question. I'm repeatedly telling that. Yeah, I'm asking the question like this. Why there is a resistance? Why we use resistors? Your answer is correct. Why we use resistors? Resistors use karane waguttare hari. Mama hanne ai resistance කියලා එකක් තියෙන්නේ. Why there is a resistance? Resistance means what? So let me go back to the note. Resistance means materials tendency to resist the flow of charge. Current එක අඩු කරන්න තියෙන ගති ගුණයට තමයි. Current එක යන එක අඩු කරගන්න. අඩු කරන්න තියෙන ගති ගුණය තමයි resistance කියලා කියන්නේ. ඇයි resistance එකක් එන්නේ conductors වලට? Why there is a resistance? That is what I am asking. එන්න පුළුවන් මොන හේතු නිසාද resistance එකක් එන්නේ? Use කරන්නයි කියලා නෙමෙයි අහන්නේ. මොන හේතු? What are the reasons? Why there is a resistance? What can be the reason? Okay, so one thing is like, if you're not answering, let me tell. One thing is can be due to the material. But there are different materials now. So can be iron, can be lead, can be different type of wires, aluminium, tin, likewise different type of wires are there now. So based on the metal, different metals having different like resistance. Electrical. So different materials are having different resistance. So you can see here. Let me show this to you. Right, you can see silver, copper, gold, aluminium, different materials. In the other, here you can see the resistance, conductivity, resistivity. And you can see some are having like higher resistance, some are having lower resistance. This is like measured in ohms. This is measured in ohms. So some are having less resistance, but some are having more resistance. Right? Some are having more resistance. Some are having more resistance and some are having less resistance. That can be due to the material. So one reason is material. The other reason is, so due to certain climate conditions. Due to certain climate conditions, due to certain external interferences, there can be resistance. Samata Ushnatve venas vunama, so different temperatures, different resistance. Ushnatve venas vunama, resistance venas wenna පුළුවන්. ඒකක්. සමහර ඒවා තියෙනවා magnetic fields. බාහිර තියෙන චුම්බක ක්ෂේත්‍රය වෙනස් වුණාම resistance වෙනස් වෙනවා. එහෙම වෙන්නත් පුළුවන්. Right? So different materials having different resistivity, and also different conditions will give different resistivity. So why resistivity is there? Resistivity එක කියන්නේ මේ ඉලෙක්ට්‍රෝන ගලා යන්න සාමාන්‍ය විදිහට ඉඩ දෙන්නේ නැහැ. සමහර ඒවා හරියට ඉලෙක්ට්‍රෝන යන්නේ නැහැ. The water, let's take water. So what do you think? Through water, is it like conductive or not conductive? Water? Water hara current again. Is it conductive or not conductive? Yes. Water hara current again.
Conductive less electric current.
Yeah, it is conductive. Current again. Right, but there is a resistance. Electrical resistance is there. The water hara අර වගේම යන්නේ නැහැ. ඒතර resistivity එකක් තියෙනවා. There is a electronic resistivity in water. You can see this is the resistivity of pure water is more resistant. Pure water is more resistant. Distilled water less resistant. Rainwater it's around 20. This is ohm per centimeter, right? You can see tap water, right? Very less in tap water. You can see very less resistivity. Sea water and like this is like very less resistivity. Pure water is more resistant. The pure water වල iron වර්ග එක එක දිය වෙලා නැහැ. ඒතර ඒකේ resistance එක ගොඩාක් වැඩි. Right? Pure water වල resistivity ගොඩක් වැඩි. අනිත් මේක centimeter එක තියෙනවා. Centimeter resistivity. When you are like, when it is far away, resistivity will be very high. You will not get it. But theta vatura binduවක් වැටෙන තිබුණොත් සමහරවිට resistivity එක short වෙන්න පුළුවන්. ඔය ගොඩාක් ඈතට වතුරේ ගෑවිලා තියෙන වයර් එකකින් ලොකු ඈතකට කරන්ට් එක වදින්නේ නැහැ. So that is the other hand. Resistivity is closer. When you are closer, resistivity is low, but when you are far away, the resistivity will be more. That is the nature. Okay, let's move to the lesson. Resistance of a conductor. To check this, like you are given different materials, type of wire. So, and you are asked to check whether the like illumination of the bulb and actually ammeter reading, amperage. So copper, basically the bright illumination. Iron will be less than that, and nickel will be less than that. If you have these wires, you can test this with different wires: copper, iron, aluminium, nickel and chromium. Right? Different materials will have different resistivity. Okay, resistivity is measured using this symbol. This is read as ohm. Make ohm කියලා තමයි ගෝට්ට කියන එක තමයි ඉන්දියාවේ ohm. 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 The symbol to denote is R, and it is measured using ohms. 1000 ohm is equal to how many kilo ohms? 1000 ohms equal to 1 kilo ohm. Then 1000 kilo ohm is equal to 1 mega ohm. Kilo ohm, mega ohm. When there is like kilo ohm resistivity, you will not actually, mostly you will not pass that much of current to the other media. Okay, these are different type of resistors, right? This like you can see this kind of resistors you have seen, but there are some different kind of resistors too. Actually, these are the symbols for resistors. So one is like this, the other one is, these are the different symbols which for resistors. Okay, let's see the so this resistor, this is called potentiometer. So let's add that and see what will happen to the resistance. This is like a this is providing a variable resistance. You can change the resistance. Make a resistance by changing the resistance, you can get different voltages. Let's put a potentiometer and see. So let's go to Tinkercad with me. And actually here, instead of the resistor, can you please add a potentiometer? This one. It has two edges, terminal, wiper, terminal 2. Oh, I can use the potentiometer. Is there? Diode is there. Let's go to all the types. Okay, let's use this. Okay, first of all, try to connect the potentiometer and see. So what will happen when you change the value when you like rotate this? Okay, when you are connecting, like you have to connect like this, the terminal, this terminal, you can connect this to a bulb. Oh, sorry, we have to use the middle one, right? That is the controlling partner. Then one edge of this to the positive edge, the other to the negative edge, right? I'll connect it here. You can see, let me measure the voltage. That is also clearly required. Let's stop this. And change the potentiometer. Please measure this time to time. So please create this setup. You can see initially bulb will get 2.3. This is more than enough. So then what you can do is you can just change this potentiometer, you can rotate it. And by rotating, what you can do, you can control the voltage. This is actually mini volt 0. So potentiometer will not pass the current. Here actually potentiometer will pass full current, but when you increase a little, here 1.7. Then if you use another, when in this case, if you are using another potentiometer, actually it's like a radio volume control button. By rotating, you can change the resistance. By rotating, you can change the resistance. Okay, let's use another multimeter. Need to connect analog. Let's run this now. You can see here it is how we have connected. On the other hand, positive edge. Okay, you can see here. It's controlling the power. It's controlling the power. That is why the potentiometer is used when you are rotating or changing. You can see. You are measuring the same location, but you can change it. Measuring the potentiometer current. Okay, see, because this is a variable resistor. Variable resistor means this resistor can take variable values. When you reduce entire power, everything will be given, but still there is a small drop because 3 volt is there, but you are not getting that 3 volt, 2.3 voltage. Because small resistance will be there in the potentiometer. When you increase or when you rotate the potentiometer, you can control this. Likewise, you can change the volume, you can change the light brightness, etc. So please try this quickly. Let me know once you're done. Yeah, LDR is light depending, yes. So LDR, so that is a light sensitive one. So you can use LDR. I think LDR is here. LDR. Oh, isn't it there? So let's go to all force, IR, PIR, LED, then what DC, piezo, IR. Regulator is there. Relays are there. LDR is not here. But it's there. Anyway, photoresistor. This photoresistor is there. Right? Photoresistor is basically you can use for that. So that is also a type of resistor. Photoresistor is also a type of resistor. Yes. Right. Try to connect photoresistor and see. So photoresistor is basically the resistance depend on the. So you can connect LED and see resistance depend on the light condition. That is what the photoresistor is. Connect and see. That is also very important. Connect and see photoresistor. You can use maybe Arduino. We have learned that in IT class. If you can remember, you can use Arduino and connect to a photoresistor, and you can start coding there. Just connect that to a photoresistor, and then try to light. So this is light dependent resistor. We call LDR. Or light dependent resistor. Basically, we can connect LDR to 5 volt, and also the other end you can ground, and then you can take input from that. That is basically analog input, and you can read it. So what is the resistance? You can read it using a diagram. So let's use Arduino board and try to connect Arduino. or you can use microbit also. Here, let me connect this. This is my Arduino board, and I can connect one terminal of the LDR to 5 voltage. So let's keep it here. One terminal of photoresistor to 5 voltage. Let's connect the 5 volt. The other terminal, I can read it using analog input. Let's remove the LED for the movement and the battery. The other terminal I can connect to analog reading, maybe A1, just for reading this analog signal. And also to stop this, like I need to ground this also. Let's use a resistor and ground this. General resistor. And through a resistor, we can just ground this while reading, right? Okay, let's provide a resistor there. This side you can ground GND. This is very simple connection. 5 voltage just to activate, or you can give even 3.3 voltage then. Okay, then you can read it. Right, you can read it just using. Okay, let's simulate this first, and here you can change the different light conditions. Change this, like this is because we are actually not exposing the light, so you have this variable light thing, and you are just using this basically using, you can use a serial monitor and just print the light level. So based on light level, you can do something based on the light level. So you can use the serial monitor. There's something called serial monitor for reading this. Or you can connect LED based on this. You can just change the light of LED also. That is another thing. Let's get this input. I'll do this connect quickly, but this is not related to science, right? So don't think this as a science lesson. I'm just showing, because you have asked about LDR, I'm just showing you the thing, but this is not related to science. I'm just showing it has variable. So you can say A0 is our input. So this is extra for your extra knowledge, right? Then let's use LED pin mode. Let's say I need to the 12, pin number 12 to be output, right? Actually, based on the input, I just need to change the output. Based on the input, I need to, before that, I would like to initial the serial monitor. This is to check whether, so what is the amount of resistance there in the serial. And then in the loop, I'm trying to read the sensor value. Let's say int sensor value is equal to, I'm going to read analog signal, analog read, which is coming from A0. That is where we have connected this. I'm going to read it and then just printing this to the serial monitor. Serial.print ln this SB that we have taken from here. So let's run that. And then here I need to activate the serial monitor. Here you can see it's 6. It's all S6, right? It's all S6. Let's remove the coding part. Then I cannot see the, when I remove the coding part, I cannot see. Okay, let's keep it here. I'm adjusting the light level. I'm adjusting the light level like this. Now you can see the serial monitor comes with a different reading. I'm adjusting the light level. So serial monitor will come with a different reading. I'm adjusting the light level. The serial monitor will come with a different reading. When I'm adjusting the light, or when the light is changing, the serial monitor value will be different. එතකොට දැන් ඉර පායන තැන මේක තියලා තිබ්බනම් x sensor base යන්නේ. ඉර පායන තැන මේක තියලා තිබ්බනම් ඉර එළිය වැටෙන විදිහට light එක මේ resistance එක මේකෙන් එන resistance reading එක වෙනස් වෙනවා. ඒක තමයි අතරම වෙන්නේ. ඒ අනුව අපිට පුළුවන් වුණා නම් LED එකක brightness එක තීරණය කරන්න. We can light up LED based on that resistance. මේ resistance එක අරගෙන ඒක අපිට LED එකකට දෙන්න පුළුවන්. Right? We can change LED light based on that. ඊට පායනකොට සමහරට ඉරේලිය මේ අපිට if එකක් දාලා කියන්න පුළුවන් ඉරේලිය ටිකක් වැඩිපුර වැටෙනකොට මේ ලයිට් එක පත්තු වෙන්නේ. ඉරේලිය අඩු වෙනකොට ඕෆ් වෙනවා. එහෙම කරනවා නම් කොහොමද කරන්නේ? මේ වගේ ඒවා තියෙනවනේ sensor based system. මේක ඔයාලට IT වලත් තියෙනවා. In IT also you have this. Therefore let me show that. So you can check, you can do if sorry, let's stop. අපි බලමු ඉරේලිය සාමාන්‍යයෙන් this S serial value let's say if it is greater than 500. If it is greater than 500, so you can turn on the light. Light අඩු වෙනකොට නේ. Light එක අඩු වෙනකොට පත් වෙනවා. If it is less than 500, you can say digital write this 12, you can write high. Then you can say delay 1000 milliseconds, and else digital write low and delay 1000 milliseconds. So what will happen here? Actually, I need LED now. So let's connect LED very quickly. Just understand the scenario. Don't try to understand the coding because we are not in a coding class or IT class. Just understand what is happening there. I just need to ground this, and this should be connected to 12, D12, and this should be grounded. Now let's try that. You can see LED is turned on. The LED is turned on. So let's increase the LED light. Still LED is turned on. Let's increase the light. Now you can see LED has turned on. This is a sensor based system now. Auto light off when sunlight is there, so this will turn off. Again it will turn off. When sunlight is there, again it will turn off. When sunlight is not there, it will automatically turn off. So now we have a sensor based system. This is in LDR. Actually, we are using the resistance because LDR or this photoresistor, another name for LDR photoresistor. Why we are using to generate variables. So this resistance will be vary based on the light. That's it. Just get an idea, right? Okay. Now we are done with that. And as a summary, we just learned about voltage, amperage, and resistance. Those are the three properties that we have already learned about this electronic circuit. So let's answer the questions very quickly. Question number 1 and 2. Can you send the answers very quickly to the chat? Question number 1 and 2. Please send it to the chat very quickly. Don't take much time. Just send the answers to the chat. Electric current flow of blank. Through a closed circuit, electric current flow is a flow of what?
Electrons.
Flow of electrons. Okay. Through a closed circuit, always electric current flows from high electric potential to low electric potential. Yeah. High electric potential to a low electric potential. Yes. So then terminal is placed on a cell where the electric potential is high. Positive terminal is placed in a cell where electron potential is high, and negative place where the electron potential is low. Electric potential is low. Okay. The figure below shows setup prepared by a student to measure the potential difference between two ends of it. Is the circuit suitable for this purpose? Potential difference they are going to measure. Sorry?
No, sir.
No. Yeah. Is this circuit suitable for the purpose? Yes. Is it circuit suitable for measuring this?
No, sir.
No. So it's not like you cannot connect voltmeter like this. Then what you're going to measure actually, the circuit is not completed. How do you measure the potentiality? To measure the potentiality, you have to connect this parallel, not serial. So give the reason. So voltmeter, yes, voltmeter is connected serially, not parallelly. So you here, can you remember? So how we have connected? To measure that, we need to connect this parallelly, right? The voltmeter need to be connected parallel. So bulb's potentiality will be measured by connecting this parallel. The motor's potentiality will be measured, or the bulb potentiality will be measured by connecting parallel. But here, it's connected serials. How can you measure the difference? So that's not going to happen. Therefore, it's wrong. And the reason is connected serial, need to connect. If any defect, correct it and draw the circuit again. So what you can do? You can just complete the circuit like this. And that is it, right? Just connect wire from here to here. When you connect wire from here to here, then here you need to connect this. If you are measuring the bulb, this node need to be connected to voltmeter, and the other node need to be connected to here. Actually, this you need to erase. This you need to erase. You don't have this. Just use some brush. You don't have this. The voltmeter is connected to this edge and this edge, and you don't have this as well. Then you can see the voltmeter is connected from bulb. Bulb, this positive and negative side, voltmeter is connected. Then bulb is given power. You've seen that. This is how circuit. Mention two facts that should be considered when connecting a voltmeter to the circuit. If you want to measure the potential difference, you have to connect to the nodes where the potential difference can be considered. Actually, in between that, there should be a device or kind of resistance should be there. Otherwise, no potential difference will be measured. That's it. Is there any other questions? Yes, two more questions. I think this is a motor, right? Given below is a circuit prepared by students to rotate cardboard disc using electric motor. To decrease the rotational speed of this motor, what property of circuit should be increased? To decrease the speed, what should be increased? Hello? If you want to decrease the speed of the motor, what should be increased?
Current.
Current එක වැඩි කරොත් මෝටරේ හිමීට කැරකෙනවද?
No.
මෝටරේ ස්පීඩ් එක අඩු කරන්න අහන්නේ හරි. Decrease the speed of motor. මෝටරේ ස්පීඩ් එක අඩු කරන්න වැඩි කරන්න ඕන මොනවද කියලා? කරන්ට් එක අඩු කරොත් හරියන්නේ. කරන්ට් එක වැඩි කරොත් හරියනවද? ධාරාව වැඩි කරොත් හරියන්නේ. පවර් එක වැඩි කරොත් හරියන්නේ. ධාරාවෙන් කියන්නේ කොච්චර වෙලාවක් මේක පුළුවන්ද කියලා රන් කරන්න. වෝල්ටේජ් එක තමයි මේකේ. අපි වෝල්ටේජ් එක වැඩි කරොත් මේකේ මේ ස්පීඩ් රොටේෂනල් ස්පීඩ් එක වැඩි වෙනවා. සමහරට පිච් එකක් පුළුවන්. So what should be increased? Speed එක decrease කරන්න increase කරන්න ඕන මොකක්ද? Just learn. That is resistance, right? Resistance නේ increase කරන්න ඕන.
Yes, sir.
එතකොට resistance කොහොමද අපි ඒක change කරන්නේ? අපිට දාන්න පුළුවන් potentiometer එක. හරි variable resistance නේ දෙන්න ඕනේ. එකම resistance එක දීලා බෑනේ. potentiometer එකක් දැම්ම අපිට පුළුවන් ඒක control කරලා අපි අර කලින් කරා වගේ. We can use a potentiometer to. So list out of 3 instances in day-to-day life while measuring the voltage and current is important. Where you need to measure. We have discussed enough. If vehicle battery, so if a toy, right, if maybe electric device or part of electric device is not working or electric device is not working. So when circuit is like, when you want to check whether circuit is properly connected to a battery, when a vehicle not start, right? When you cannot see the reaction of circuit, maybe bulb is not turning on, the fan is not rotating. In these things, you have to measure this voltage. Okay, with that, I hope we have done the lesson. Next day, we need to discuss about 8th lesson, that is status of matter. Actually, we have already discussed some parts of this, but need to do some practical revision. And after that, the lesson number 8, after the lesson number 8, we can finish the book 1 and move to the book 2. That is about the status of matter. And so what about the school syllabus? Like, I just want to know whether are we on the track or are we late? If so, if we are late, we need to increase the number of hours. So now we are in the 8th chapter. So what about the school? Have you completed all the chapters in the book 1? Sanidhi?
We are also in the 8th chapter, sir.
8th chapter, right? Okay. So then I think, so when is your term going to be end? Is it in December or is it in March? March or December? Term in
March.
March. That then we have time, right? Okay, let's proceed with that timeline then, right? So I think we are on the time. So I'm just checking whether we need to increase the number of minutes, because still we are discussing only 1 hour. I thought that 1 hour will be enough because these lessons are not that much depth. But when it comes to grade 9, 10, we need to increase the number of hours here. For grade 4, 6, 7, 8, 1 hour will be enough. Let's move to the chapter 8 next week. We can start the other lesson after finishing that. We need 2 days to finish the change of matter, status of matter or change of matter. We need to spend 2 days. And after that, we can move to the next book. Okay, good night. See you next week.
Yes, sir. Thank you, sir. Good night, sir.